Hurricane Harvey, Hurricane Maria, natural disasters that will go down in the history of certain communities as the big one. Hurricanes and floods are disasters for human communities because of the loss of life and property and the damage to infrastructure. When I consider the recent hurricanes as an environmental scientist, however, I do not see them just as disasters. My perspective is informed by two fundamental aspects of environmental science. Large hurricanes and other disturbances are a natural part of the environment, and our alterations of the natural environment may exacerbate the impacts of disasters on human communities. In photographs taken since Maria, the forests of Puerto Rico are nearly unrecognizable. I remember a densely vegetated, intensely green forest from my visits there. Woody vines snake up the trunks of trees and twine through the forest canopy, where branches look furry in their coats of epiphytes and bromeliads. Malachite green mosses cover fallen logs and emerald green algae grow over the cobbles in the stream. Now the forests are the brown of stripped and scarified wood and fallen leaves. The Onetwa punch of Irma and Maria, and the shearing and pummeling of intense winds, shredded the greenery, leaving a tangle of downed wood and standing, splintered trunks. It looks like a disaster. But, just as one woman's trash is another woman's treasure, this is an opportunity for many organisms. People who live in my part of the world, the dry interior of the western United States, have grown to understand that plants such as ponderosa pine only thrive in a landscape with periodic wildfires. The seeds of some plants can only sprout and grow following fire. Other plants require abundant sunlight to grow, which reaches the forest floor only after a wildfire reduces the shading from larger trees. Bark beetles move into a burned forest to burrow into the standing dead trees, and woodpeckers follow the bark beetles. Even as new trees grow over the next few decades, cavity-nesting birds benefit from the standing dead trees left by the fire. Even extensive fires are capricious, leaving unburned patches scattered among the blackened, smoke-scented snags, and enhancing the diversity of plant and animal species and the age structure of the forest. Sierra Palm Forest, Puerto Rico, before the storm. Ellen Wohl, used with permission. When Hurricane Hugo roared through eastern Puerto Rico in 1989, environmental scientists who had studied the region for years watched in awe as the forest changed dramatically in a few days, and then rebounded within months. Stream ecologists found that formerly shaded streams experienced a population boom of algae as sunlight reached the stream bed and decomposing leaves provided critical nutrients. Aquatic insects that feed on algae became superabundant, as did the freshwater shrimp that feed on algae and on leaves partly decomposed by microbes. Branches and palm fronds piled up in debris dams more than 3 feet high across small streams, increasing space for microbes, insects, fish, and shrimp to live in. Within 6 months, the debris dams gradually decayed and dispersed, vegetation regrew and once more shaded the streams, and the types of organisms in the streams resembled those present prior to the hurricane. This resilience is why ecologists refer to hurricanes or fires as disturbances, rather than disasters. Hurricanes kill some organisms and alter the ecosystem, but they do not destroy everything. Forest ecologists watching trees spurt up to claim their place in the sun found that plant regrowth after Hugo was 2 to 3 times as fast as in portions of the forest not disturbed by the hurricane. 3 years after Hugo, the forest had largely recovered the amount of vegetation it had previously, although the age and types of plants changed. One organism's disaster is another's disturbance opportunity. Like wildfires in dryland forests or floods in rivers, hurricanes and other natural disturbances can help to maintain ecosystem health by creating opportunities for pioneer species that increase biodiversity and for younger plants that increase the age and diversity of the forest. The rapid regrowth of plants and recolonization by animals following hurricanes illustrates how natural communities can be resilient to disturbance and even depend on periodic disturbance to maintain ecosystem health. This is an understanding of natural disasters that comes to us from the work of environmental scientists. Puerto Rico after the storm. Omar Gutierrez del Arroyo Santiago, used with permission. Another understanding comes from environmental scientists who examine how human communities influence and respond to natural disasters. Environmental geologists illuminate the ways in which levees and river channelization exacerbate flood damages downstream by reducing the ability of water to spread onto floodplains, or roads increase landsliding during hurricanes by concentrating downslope movement of water. Environmental geologists also guide planners and citizens toward patterns of land use that may reduce death and economic damages during natural disasters. Ecologists and conservation biologists explain how river channelization, roads, removal of riverside vegetation, and urbanization limit the resilience of natural communities by reducing the abundance and diversity of new habitat following a disturbance and by limiting the migration pathways available to plants and animals following disturbance. Social scientists take note of the manner in which loss of life and property can bring members of a human community emotionally closer as they realize their interdependence and work to save each other. This facet of environmental science situates us, and our actions, in a context of dynamic natural systems that periodically experience extremes of climate and geology. Disaster comes from dis and astrum, as in star, and an older meaning for the word is a baleful aspect of a planet or star. Does the fault of a natural disaster lie in us or in our stars? A little of both. Geological records of natural disasters indicate that these disturbances have a history as long as that of living organisms on Earth. Our preparedness for natural disasters and our resilience to them depend on our understanding of these disturbances on our rapidly changing planet. If we can continue to develop this understanding, we may be able to lessen the negative impact of disasters and in turn see a way to a brighter future. Featured image credit Puerto Rico before the storm. Ellen Wool, used with permission.